So we're going to find the volume of the solid generated for y equals 3 times 2 minus x, and with the restrictions of y equals 0 and x equals 0, and we're going to rotate this around the y-axis. I drew a quick graph of it, and so you get an idea of what it looks like. The red line there is y equals 3 times 2 minus x, and we're going to rotate it around the y-axis, which is this line that goes straight up and down. And if you kind of visualize it, it looks like it's a triangle, and if you could rotate it around the y-axis, you visualize that in your head, it looks like it's going to be a cone, and the volume for a cone is going to be 1/3 pi r squared h. And the radius of this would be 2, and the height appears to be 6. So if we plug those numbers in, we're going to have 1/3 times pi times the radius squared times 6 for the height. And if we simplify that, 2 squared is 4. 4 times 6 is 24. 1/3 of 24 is 8. We're going to have 8 pi. Now if we try to use this with calculus, we can use the shell method here, which is going to be 2 pi times x times our function d of x. First, let's also distribute the 3 here. So 3 times 2 is 6, and 3 minus x is negative 3x. So if we didn't have technology, we still want to find out the value of where the lines are going to intersect. So we would need to solve this for 0, because we have an x equals 0 there. So that would give us y equals 6 minus 3 times 0, y equals 6. We need to graph this by hand. And then also, if we set this equal to 0 for y, 0 is going to equal 6 minus 3x. It's going to be trivial for your calculus students. Subtract 6 and divide by negative 3, and that's going to give us x equals 2, which is down there. We can see that's going to be a restriction. So we're going to do the integral from 0 to 2 of 2 pi times x times our function, which is going to be 6 minus 3x dx. I'm going to bring the 2 pi up in front because 2 pi is a coefficient, and then I'm going to distribute the x in one step here. So we're going to have 2 pi times the integral from 0 to 2 of 6x minus 3x squared dx. And now we need to actually take the antiderivative. The antiderivative of 6x, we add 1 to the exponent, and then we divide, which would be 2 up there, and then we divide by the 2. So that's going to give us 3x squared. And likewise for negative 3x squared, we add 1 to the exponent. That's going to give us a 3, and then we would divide by 3 down here, which is going to be 1, so it's just going to be a minus the x cubed. Now it's just going to be a little bit of calculation work. Putting the 0 in is going to be trivial for this, because we're just going to have 3 times 0 minus 0 to the 3rd power. So we don't need to do that. But we do need to put in the 2. And that's going to be, just write out the 2 pi. 3 times 2 squared minus 2 to the 3rd power. 3 times 2 squared. 2 squared is 4, times 3 is 12, and 2 to the 3rd power is 8. Simplify what's inside the brackets, so that's going to be 2 pi times 4, which is going to be 8 pi is going to be our volume, which matches up with what we did with the geometry method.